Hello everyone, welcome back to the video lectures of Python series. Today's topic is order of operations or the precedence rule in Python. The concept of a precedence of operation or precedence rule is about the kind of Bodimer's rule that we have studied in school mathematics. So there we have seen Bodimer's is nothing but brackets of division, multiplication, addition and subtraction. That means the priority happens from Bodimer's and then the last priority is given for the addition. The first priority is for brackets ending up with the subtraction part. Similarly in Python operators as well, we have to follow the kind of priority. So here we are speaking about PEMDAS, PEMDAS. So here P represents parenthesis where all the expressions inside the flower braces and the normal braces are to be evaluated first, followed by the exponents which has powers and roots. Next is multiplication and division elements where the first priority is given for multiplication and then followed by the division part. The last one is as AS, that is addition and subtraction part. First priority is for addition and the second priority is given for the subtraction part. So let's try to understand this in detail with an example in the coming slide. As of now, in Python, we have so many operators involved and using this basic rule we are going to evaluate the expression to give a correct output or the correct value. So the Python interpreter also follows the same sequence of handling the operators. First one parentheses, next one exponents which handles powers and roots, next multiplication, next division, followed by addition and subtraction. And the precedence of operators is listed from high to low. So let's take an example and make the concept little more detailed. So here, when I have as we can see here, coming to the first preference, that is parenthesis, in the example given below, 2 into 3 minus 1. So what has to be evaluated here first? 3 minus 1 has to be evaluated as it is placed inside the parenthesis, which gives you 2, and 2 into 2 is 4, and same way you can evaluate the next expression also, which gives you 8. And then is your exponential part, which has the second preference. So you see here I have 1 plus 2 power 3. So which has to be evaluated first? Is it the exponential part or the addition part? So here you have to evaluate 2 power 3 first, which turns out to be 8, and then add up this one to 1. And same way the next priority sequence goes for multiplication and division followed by the addition and subtraction. Let's take a solid overall expression and try to solve it using PEMDAS. So here is an expression provided, 58 divided by 4 into 5 provided in parentheses plus 3 power 2. So let's apply all the concepts of PEMDAS over here. So what has to be removed first? So first we have to evaluate the parentheses. So that is step number 1, where 4 into 5 is 20. So that 20 we placed here and kept our first step ready. So after P, the exponentiation takes the next priority. So where is the exponentiation part? So here. So what we have to do? We have to apply the concept of exponential and the final answer turns out to be 9 here. So replace that 9 in the expression. So finally we are having 9, that is 58 divided by 20 plus 9, followed by M or D. So PEMDAS. So here we don't have multiplication, but you have to go for the division part. So first we have to divide the elements. So what has to be divided? We need to divide 58 and 20, whose value is equal to 2.9, and then add up with the remaining value, that is 9, because the priority has to be given for the division part after parenthesis and exponentiation. And the last one is either addition or subtraction. So we have the addition part left over here. So directly add up and then find out the answer. The perfect answer of the above expression is 11.99. So this is how the interpreter of the Python undergoes or follows the priority operations to give you a desired or a perfect output. So hope the concept of PEMDAS is clear. So let's move on to the next important topics, that is functions, in the coming video lectures. Thank you very much.